Okay, everybody, so we are going to work on doing the distance formula. Okay, so distance formula is going to be x sub 2 minus y sub 2 squared plus y sub 2 minus x sub 2 squared. We are going to find the distance between these 2 points. Okay, so if you look at these points, notice we knew which one to put where. Okay, so we're going to make sure, so like this one would be our 2 is less than 7, so that's going to be our first point, and then this would be our second point. Okay, we're going to do keep, change, change, keep, change, change. Everybody, this will help us with our negative. Same sign, just add, so negative 4 plus negative 3 is going to be negative 7. 2 plus negative 2 is going to be 5. Okay, and then we square both of those, so we're going to get 25 plus 49. 25 plus 49 is 74. And then we're going to take the square root. Okay, so, and we're going to round to the 10th place. So that's going to be, so we get 8 and 6/10, 600, sorry, 60 hundredths. So this everybody is the 10th place. That's our first decimal place. We look at this number after 5 and up, rounded up. So we're going to leave it at 8 and 6/10. So that would be the distance between those 2 points. Okay, so now we're going to find the distance. Okay, again, everybody, you want to go ahead and label them. So negative 4 is less than 6. So I'm looking at the x coordinate, everybody. That's how I know it's going to be the smaller one. And then we substitute our points into our formula. Okay, we're going to do again, everybody, keep, change, change. So keep, change, change, keep, change, change. Everybody can also just enter it all like this in the calculator. The only thing, or in decimals, the only thing is you have to do this. So add an extra parentheses just so it does this part first before it does the square root. Okay. And then, so 10 squared plus 10 squared is going to be 100. 100 plus 100 is going to be 200. We're going to take the square root of that. I put it in the calculator and I got 14. Remember, we're rounding to the 10th place, everybody, and 14 hundredths. Okay, first decimal place, 5 and up, rounded up, so we're going to leave it as 14 and 1/10. Okay, so again, everybody read the directions carefully. Pythagorean theorem. So that's the sum of the squares of the legs is equal to the square of the hypotenuse. We're going to find the distance between A and B. Okay, so notice that A is on the right, so just be careful, everybody, that you're looking, and we want to know the distance between these. Okay, so we can do on the graph, everybody, where we count the length, so that would be 6. Okay, and then this would be 5. Okay, so so our base is 5. Our other leg is 6, and we're trying to find C. So we're trying to find that length, and we're going to substitute them in using our Pythagorean theorem. So it's going to be 6 squared plus 5 squared is equal to C squared. 6 squared is 36. 5 squared is 25. Okay, and then we're going to add those together to get 61 is equal to C squared. We're going to take the square root of each side. Got to get to the root of the problem, everybody. So we take the square root. Again, everybody, it's the same thing. We're rounding to the 10th place. So I get 7 81 hundredths, 5 and up, rounded up. So that means I'm going to leave it at 8. Okay, everybody, because I'm looking at this, the number after. Okay, we're going to do another one. Okay, so between A and B again, so we're going to find the distance. And it's going to be 4. Okay, And then our base is also 4. And our hypotenuse is always our longest side for right triangles and diagonally across. So we're going to use Pythagorean theorem. So I'm going to substitute in 4 for A, 4 for B. 4 squared is 16. 16 plus 16 is 32. And then we take the square root, everybody. So I'm going to take the square root. Again, got to get to the root of the problem. And it's square root of 32, which is a radical. So we get 5 and 65 hundredths. We're going to take this and we're going to round it up, okay, because it's 5 and up rounded up. So we're going to round it to 5 and 7/10. Okay, everybody, you got this.